Hi, here we have another question from Leningrad Mathematical Olympiad 1970. The question was given to 8th grade students. We have a set of equations and we should find a solution for this set of equations. You can spend maybe around 10 minutes to solve this question and then come back and see the solution. Okay, so here we have the equations. First thing that we do is to subtract equation 2 from equation 1. So obviously x2 with x2 disappears, z2 minus y2. Here we can factorize x, z minus y. We can also decompose z2 minus y2 into z minus y times z plus y. Now we can factorize z minus y. We get z minus y times z plus y plus x is equal to 40. Okay, next step we are going to subtract the third equation from the second equation. z2 with z2 disappear, y2 minus x2, z times y minus x. Again, we decompose this one, y minus x times y plus x, we factorize y minus x, and we get y minus x times z plus y plus x is equal to 7. Assuming that x plus y plus z is not 0, we can divide these two equations and get z minus y divided by y minus x is equal to 2. And we can multiply this one to 2. So 2y minus 2x is equal to z minus y goes the other side. Z becomes 3y minus 2x. Now first let us see what happens if x plus y plus z is equal to 0. If this is the case, obviously we can find z is equal minus x plus y. We take the second equation and we are going to replace z with its equivalent, which is minus x plus y. Okay, so we get to this equation, we multiply, this becomes x2, this is minus x2 minus xy, here is x2 plus 2xy plus y2, this one with this disappears, this one with this disappears, so we get to this equation. But from the first equation, we know that x2 plus xy plus y2 is equal to 7, so this is contradiction, therefore we conclude that x plus y plus z is not equal to 0. Okay, we have already shown that if x plus y plus z is not 0, z becomes equal to 3y minus 2x. Here's our first equation. We are going to replace z into our first equation. So x2 plus x times 3y minus 2x plus 3y minus 2x power 2 is equal to 21. We expand this. This is 3xy minus 2x2. This is 9y2, 4x2 minus 2 times first one times the second one. This is minus 12xy. We can simplify. This is 4, 5 minus 2 is 3x2. 12, 3 is minus 9. And here we have 9y2. We can divide both sides by 3. Okay, so this gives us x2 minus 3xy plus 3y2 is equal to 7. Now we can rewrite this a little bit so that we use the first equation in this equation that we obtained. So basically we write it as x2 plus xy plus y2 so that we create the first equation. And then we added xy, so we subtract one more xy, so minus 4xy plus xy, it's minus 3xy. Here we take out 1y2, so we would be left with 2y2 is equal to 7. But we know that this term itself is equal to 7. Therefore, we conclude that minus 4xy plus 2y2 is equal to 0. All right. So now we have this equation. So now we can factor 2y from this. And basically we get 2y times 2x minus y is equal to 0. There was a minus also here, but that one's not important. So this one results that either y is 0 or y is equal to x. So first we consider if y is 0, what happens? Okay, so this is easy because we know that from the first equation, these two become 0. From the third equation, these two become 0. So x2 becomes 7 and z2 becomes 28. That means x is plus minus square root of 7. Z is plus minus 2 square root of 7. 28 is 4 times 7. So if you take a square root, it becomes 2 square root of 7. Now we don't know if all of these solutions are acceptable or not. We are going to place it into the second equation. So we notice that second equation is equal to 21. So z2 is 28, x2 is 7. So if x times z is also a positive number, then the second equation will not be valid. So x times z should be a negative number. That means we can either use a square root of 7 here and minus 2 square root of 7 for z, or the other way around, so that when we multiply them together, it creates a negative number. That means one of the solution is a square root of 7, 0, minus 2 square root of 7, and one of the solution will be minus a square root of 7, 0, 2 square root of 7. Okay, now the second scenario is if y is equal to x. So in that case, we take the first equation, we replace y equal to 2x. Obviously, here will be 2x multiply x2, x2. This is 4x2. This is totally 7x2 equal to 7. So x2 will be 1. Okay. So if x2 is equal to 1, that means x is either 1 or minus 1. But because we know that y is 2x, so either we have xy is 1 and 2, or xy is minus 1 and minus 2. All right. In order to find z, you can just plug one of these number in any of these equations, or we can subtract these two equations. So 28 minus 21 is 7. Z2 disappears. Y2 minus x2 plus z times y minus x is equal to 7. This is 4. This is 1. So it becomes 3. 3 with 7 disappears. So we get z times y minus x is equal to 4. For one case, we have y equal to x is equal to 1. So z times 2 minus 1 is 4. So z will be 4. The other case, y is minus 2, x is minus 1. So z becomes minus 4. Okay, so here we have the full solutions for this set of equations, as you can see here. Now what we have learned is to combine the equations in order to obtain new information by simplifying them, adding them, subtracting them. Sometimes you need to multiply some numbers and then add or subtract. Eventually you get simplified equation which gives you beneficial information. And also you must remember to investigate all possible cases. You observe that in this case, we had to consider x plus y plus z is 0, or y is 0, or y is equal to x, every cases. All right, this is the end of the video. See you next time. Bye.